adapter pattern. What is the purpose of the adapter pattern? So when we have code where there's often a case that we have some data, some type, of some instance of some type that we want to actually make work as if it was an instance of a different type or interface. Basically, so but we don't want to make a copy, we want to actually make it behave like that. That's what an adapter does. It basically sits around instances of type A and makes them implement type B, and using the underlying data. And this is a very quite common pattern that you'll find in a lot of purposes. And to see some example of this, for example, on this slide. So this is a very simple implementation. It's a string adapter that basically would say, okay, it will adapt basically a list of something. Basically, a string adapter provides a list of strings. How does this work? Well, when we use this, we just want to have an adapter, and then we do something until we have we go through all the indices and we print them, something like that. And we might have data that is an array of integers. And this array of integers, we want to actually make them accessible as strings. You can create copies, but in this case we don't want to do that. And in some cases, you really the underlying data might change, so that means that you want to update this. So an adapter pattern isn't casting. So a cast is when you're actually, so there's two forms of casting in Kotlin and Java. There's basically saying, okay, I have this data and I believe it is actually of that particular type. You tell the compiler to say, okay, this value, you think it's of type A, but I know it's also of type B, so I'm telling you it is also of type B. This means that that value actually needs to be of type B, or you get an exception. There's another form of casting that is what we call, actually in better terms, coercion. The coercion is when you what you do with integers or with numbers. So it's okay, I want you to take this value and transform it into another type. Kotlin doesn't like that, but in Java you can take something like an integer and just cast it to string, and then the right thing happens. In Kotlin you need to call the right conversion method, because automatically doing those things has some problems in design. So an adapter doesn't so much. So again, an adapter doesn't transform. So a coercion creates a copy of the value. It creates a new copy of the value that is of the coerced to type. A cast will tell the compiler that what I actually have here actually is an instance of the needed type, the type B in this case. What an adapter does is says, okay, I have this object that doesn't have its own state, but it will translate between the language of type A and the language of type B. So you can take an object, you can pass it an object of type A, in this case an integer array, and then it behaves as if it was a string adapter. So that's how it works. And there is actually another adapter in this bit of code. So when we go look at those types, and I put it very small, so I expect you won't be able to see them very well. But what we have here is we have another adapter, which is a string adapter iterator. Again, it's an iterator that exposes the underlying string adapter. So this is what you can do with Kotlin to make something. Oh, I want to allow for each over something. And to allow for each, you need to basically have an iterator operator, or it needs to be implementing the iterable interface. But you can't implement an interface through an extension, but you can implement an operator as an extension. So basically, we now create a string adapter iterator on this particular string adapter. So when we do that, we store basically what is the string adapter that we're working on. This is the adapted object. And then we provide the iterator interface or an iterator string. We need another property to make this work because iterators actually do have a little bit of state. Is what is the current one? So we store the next index. And when we then need to implement both the hasNext and next functions, hasNext, we determine whether the index is still smaller than the last element in that adapter. Then every time we call this, we compare it with the size. So if that size somehow changed, the hasNext will also take that into account. Of course, this doesn't say you can only make it bigger. If you make it smaller, then all kinds of weird things may happen. You need to be very careful with changing data in the type that is actually being used somewhere else. That's an aside. And then when we call the next, we just take the string adapter, we get the string version with that particular index. And then at the end of it, we also increase this next index. So I use also here because to make it just tidy. I can use apply, but then I have a this object, which shouldn't really matter, but also is cleaner because then we just get an it that we just don't reference, and we also increase the index, but only after we get this. But the receiver of the also will be returned. And then you can have a slightly cleaner way of using this. And the operator thing will just create this adapter that creates an iterator out of a string adapter. So that's an adapter of an adapter. And yes, you can do that. An adapter is just a type. It's just a way of looking at things. So hopefully this is an idea of okay, you can actually change stuff.